If you find these videos helpful, please consider supporting AddOhms and the Bald Engineer on Patreon. Hello, and welcome to an AddOhms live stream. My name is James. I'm the Bald Engineer. This is a weekly stream, and if it's your first time to an AddOhms event, thank you for stopping by. What we're going to do is we're going to go through some news, and then I've got a electronics project that we're going to work through. This week it's going to be a little bit of a shorter stream than usual. I've got a couple of major projects I'm working on, and so I need to get working on those. I thought about streaming part of this thing I'm doing with the MSP 430, but it would be a whole lot of me just going, and so I didn't think that'd be very interesting. If you don't know, this is streamed in two places. It's streamed mostly on YouTube as well as on Twitch, and there are three places where you can chat from. Just a second. Well, so three places you can chat from: Twitch, YouTube, and we have a Discord channel or Discord server as well. So feel free to stop by that. There's a link in the description. Okay. I want to say hello to everybody in the chat room. Do one more mic check. Looks like that's working okay. Let me know how the audio is. Now, as I mentioned briefly, so this week's topic, I was going to say briefly mentioned, but I never actually said anything. We're actually going to take a look at one of these guys. It's an electronic load I got from eBay, which I'll talk about a little bit more in a second. I'm going to use this to actually test a power supply board I designed a while ago that I wanted to see how well it works. So we'll get to that in just a few minutes. But first, a couple of news items. If you're an eagle-eyed viewer, I released a video on Friday, and it was episode 27. The last official episode I released was episode 25, which was how to pull up resistor values. Episode 26 seems to be missing. Well, it's actually being hosted or shared through Element 14 at the moment. It'll be released later on AddOhms. But if you go to addohms.com/EP26, it'll redirect you to this Element 14 page, which is hosting the video. And it's on capacitive touch. So TI sent me some boards that actually have capacitive touch buttons. So I talk about how capacitive touch works. Now, if you've been following along for a while, this is going to be, you're going to start to notice there's some things leading up to something, which I'm working on a project that involves this touch stuff. And so, so it kind of leads into each other. In a few minutes, I'm actually going to show you a clip from this episode, but let's talk about a couple other things. As I just mentioned, episode 27 was out. It came out on Friday. It's where we took the Pyramid Arduino board. That's the standalone or DIY Arduino board that we designed over a couple of episodes. Got the boards back. I soldered them, threw them in the reflow oven, and debugged a couple of issues which were totally there because I wanted to show you how to debug problems. So that's live on the channel right now. Just to also note, I do have a blog that I post about every week too. It's baldengineer.com, and so there's a couple of posts I wanted to bring your attention to. There's this one on Arduino math, which is just some common math mistakes that I see people make, and it's not actually even Arduino related. It's just that's where I see it the most. These are actually C and C++ things that trip people up. The other thing I thought I'd show you is I have a tutorial on how to use an Arduino with an oscilloscope so that you can learn how to make scope measurements with just an Arduino board. And so you can go through that. I'm actually thinking about making that a video, so I'd love feedback on that. Okay, and then lastly, I was just going to show you, so this is going to be the topic for today. It's a constant load, and I'll talk about why I wanted one in just a minute. I just wanted to show you I got it on eBay. There's tons of people on eBay and AliExpress selling these. They're about $30. I don't know that I could say they're worth $30, but it does one of the functions I need it, so I think it's worth checking out. So we're going to take a look at that. So I need to set up a few things over here. So why don't you guys watch this quick clip, and then when it's done, we'll get into this week's topic. First up is self-capacitance. The sensing capacitor is a single copper pad surrounded by ground with a propagating electric field. This setup is very similar to the example we used earlier to explain how to measure capacitance. The 360-degree propagation is a good and bad thing. It is good because you can touch either side of the PCB. The downside is that means there are a larger field per button, which limits how many you can put next to each other. If we could reduce this field, we can pack in more buttons, which brings us to mutual capacitance. Well, that went a lot faster than I expected. I'll show you what I've got going on over here. So I've got my load, I've got my power supply. We're going to start with the bench power supply. Got the load. I'm going to use this as my multimeter, so let me get that going. I'm new to your channel. Why do you make so many lives? Well, because the way I do videos, they take about 100 hours for each of the scripted episodes, and so it could be 6 weeks or so between videos. So I started doing live streams because they're easier, and it gives me a chance to cover things I wouldn't normally cover. All right. My battery might have died. All right, give that a second. I need a couple of wires, and I need these guys. Okay, so the idea behind this kind of load thing is, if we look at it first, you can actually tell this is just a heatsink from a computer, which is actually a pretty clever way to do this. And then inside is you can actually see there's a MOSFET in there. And so what I think these guys are doing is the resistance between the source and the drain of the MOSFET changes so that it changes the effective load of this device. And so obviously that creates heat, and so that's why there's a massive heat sink. So let me turn this on, and because then we can kind of talk about, well, that's not good. Let's see, I didn't even think about, let's try taking this off. Does that help? Not really. All right. Okay, so right now it's on 0 amps. Basically, you set what current you want it to draw. Let's see if I can get this to cooperate. Let me check the other camera. This is something I didn't think to check last night. Yeah, it's going to be a little bit easier to see over here. All right, so this is going to set the current draw. And then the next thing is missed it. Next is what voltage should it cut out at? And so the idea is that if your load drops below a certain voltage, then this guy shuts off because it knows that something is wrong. Okay. Now, the way to hook it up, there's this port on the back, and this one is designed for what they call a 4-port measurement. And so, or a 4-wire measurement, not 4-port. That's a wrong technology. So I don't want to hook up 4 wires, so I'm just going to I just made these guys to take up both of the sockets. So we're going to go this way. Just retwist these so that they're not shorting out. And so the first thing I'm going to do is I'm going to hook this up to my bench supply just to show how it works. And then we're going to test out some of my switching regulators. Now, the reason I wanted this was because I wanted to be able to control the load that the supply is seeing so that I could get an idea of how well it was going to regulate. Ideally, when I hook this up, I should have a scope connected so that we can see what the voltage ripple looks like. And so, but I didn't feel like doing that today because the boards I'm testing are not really meant for use. They were just a test board that I made. The boards I do need are coming next week, and then I will get a scope and hook it up. Well, shucks. I was really hoping to use the multimeter. Okay. We need a screwdriver. The batteries just died in it, and so I want to, let's get that going real quick. I want to use this one though because then you can see what the multimeter is seeing in a later measurement. Be right back. Okay. Don't you hate it when batteries die? Yeah, I do. You know what I really hate is when you had a fleeting thought before hitting start to replace the batteries, but thought, nah, they'll last. I mean, the thing is these batteries have been in this multimeter for like, feels like 2 years now, and it's Bluetooth low energy, and so it doesn't actually have an on-off switch. And so it's been on for literally 2 years. And so, of course, today they finally die. That's fine. Wrong screwdriver. All right, let's see if this thing connects now. And if not, then we'll just go to backup plan. Okay, I see it has a signal, trying to connect. Well, that's a bummer. Okay. Okay, I'll have to figure that out later. Okay, so we've got this guy going. I want to unpower this for just a second. What is the watt of this fan? Well, this entire thing is designed for 150 watts, but it doesn't get 150 watts. There's no way. But that's okay. I didn't buy it because it's high power. I just bought it because it was cheap. I only need a few watts out of it, and I think it'll work fine for what I need. So the first thing we're going to test out is just my bench supply. So I'm going to hook this up to the positive side. And then hook this one, where's my negative? Hook this up to the negative. Where you bought this thing from? eBay. So the fan has an antenna to operate the fan with Wi-Fi. Nope, there is no antenna on this. It's only controlled by this this little micro, which in a teardown I saw somebody else do. Like, there's a lot to tear down. It looks like it's an 8051 based microcontroller. Okay. You know what? I bet I could do this really quickly. Let's go laptop and overhead. Configure video. Let's bring the brightness down. No, can't really see that. Increase the contrast. Does that help? Nope. Nope. All right. Yeah, I was hoping I could adjust the video to make the screen kind of, man, that was a lot easier to read though, wasn't it? It does look like that made a difference. So let's go ahead and maybe something like this. Nope. Okay. All right, I'm just going to tell you what it says because that just looks bad. Okay, so right now we got hooked up to the supply. I have my supply set to 9 volts and a 2 amp limit. Let's see. Yeah, Trent, no exposure setting. Yeah. I was actually being lazy and I'm using my webcam instead of my normal overhead camera. And now I really wish I had done that. Okay, that's okay. All it says is how much current is on it, and I'll point it at this guy in a minute. Okay, so what I'm going to do is turn on my supply. And then we're going to, let's see, what was this set for? I'm going to turn this down to 500 milliamps. I really do not like. There's got to be. Nope. Did seem like I was able to find a setting that at least gave us a number, but not really seeing it. Okay, well, I'm going to leave it there. That's what I get for using this camera. Okay, so is it DC only or AC? This is DC only. Okay, so 500 or 5 amps. I'm going to have it, the low voltage setting, I want it to be like, let's call it 8, because I have this set, the meter or the supply is set to 9. I'm going to tell this if it drops below 8 volts to stop. Okay, and now, no big deal. All we got to do is hit this button. And nothing happens. Fantastic. What in the world? Did it already break? Ah. What's going on here? Is it recommended to use this load to measure the ripple power of supplies with an oscilloscope? Well, to be honest, that's, or I guess I'm always honest. To be frank, that's why I bought it. The downside of this supply is it's a constant load. So it doesn't really represent what a real load probably looks like. but it will give you an idea of how bad something is in terms of ripple. Okay, let's try that. Okay. Okay. That's actually, my Chinese says it is low voltage because there's no supply. Turn this on, and I don't want to use metal. So the LCD right now says it's drawing 490 milliamps. And if I look at my supply, it actually says the same thing. So that's working. Now let's bump it up. So I'm going to go to 1.5 amps and see if that works. So 1.5 amps. Now this says that the supply is only outputting 8.85 volts, which I think is an interesting number. And so I want to check that real quick with my multimeter. Okay, first what we're going to do is check this out. So at the supply, I see 8.99 volts. That's what I would really expect to see. And then if we go and look at the load, we see 8.85 volts. So what's going on? Well, the wires that I'm using are these relatively thin wire. And so we're actually seeing voltage drop across the wires as current goes up. So for example, if I take this thing and let's take the current all the way to I'm going to go 1.9 volts because this supply on this output is limited to 2. We bump that one up. Now we're going to see, let's see, this is saying 8.81 volts and the multimeter says 8.81 volts. Yep, so we're losing about, what is that, 20 millivolts across the wires. Well, Trent, I'm glad that the mysterious algorithms brought you to AddOhms. Okay, you say it's better to have a CCV tester or an analog linear load and a digitally controlled load. Lance, you're asking good questions, and I gotta be frank. As I play with this load, I keep thinking it would be fun and beneficial to just build my own. And so that could be something that happens. All right, so now what I want to do is, oh man. Let's go back to here. Nope. Let's go back to here. Now what I want to do is I'm going to grab one of these boards. These are, let's see if you can see it over here. These are, actually that one doesn't work. These are a switching power supply that I made a couple of months ago. Really what I was trying to do with this supply is there is a inductor on the board. And so if you can tell, I think the cameras are good enough you can tell, this is a traditional wound ferrite inductor, and then this is what is called a metal composite inductor. So this is the metal composite, and this is the ferrite. And the difference is the metal powders. The idea is that this coil has a much higher saturation current than this coil, but usually what happens is at low currents, these are a little bit less efficient than these. So I built these to compare the difference between the coils. Now it turns out all of the boards I built with this coil don't work, and it's nothing to do with the coil. It's because it's 0402 resistors, and it turns out my reflow process can't do 0402. And so I need to redo those so that I can get the divider network. Now, what I thought would be interesting is just to show you what I'm talking about. Let's see if this is visible. Configure video default. Okay. So here is the schematic for this board. It's based on this switching controller from TI, the TPS series. So there's the oh, wait. Okay. I had a different schematic in mind, but okay. So this is the switcher output. This would be like if you were to design a discrete buck power supply. This would be the MOSFET effectively. So this comes out, charges up the coil, charges up the cap, and then we get our voltage out here. Now, this divider is actually, it's just a resistor voltage divider. It goes back to the feedback pin. This is what actually sets the output voltage of this divider. And so like on these boards that I don't have working, on all of them, one of the resistor came off. And so this is kind of sitting at an open, which is interesting because then I can actually see what the reference voltage is of this chip, but not very useful as a buck converter. Now, it turns out when I designed this, I added the enable signal. So I've got to do kind of a hokey wiring setup so that we can actually make sure that, that the converter gets enabled. And then on the output, I'm going to add a resistor. It's like 200 ohms just to make sure that there is current flowing. Because anytime you have a switching regulator, if there's no output current or if there's not enough output current, this guy can't stay within regulation. That's why when you buy like a wall wart that's rated for 12 volts, if you hook it up to a multimeter, it might measure up to 17 volts, and it's because there's no load. So all you're getting is the parasitics of the output circuit, which isn't enough to keep it in regulation. So let's get this hooked up. Stream control panel, is it custom? No. I was going to build one, and then I found that there's a company, forgot the name of the company, but the product is called a Stream Deck. And so it's got actually, all these buttons have an OLED screen, so you can configure what each of the icons look like, and then you can configure the scenes and everything for the streaming software. Okay, so we'll hook that up there. Now we are going to use the bench supply. It's going to provide current, and we need oh wait, we're not using this resistor because that's what I got the load for. What I need then is, so this is going to hook up like this. Let's go back to the overhead camera. That's hooked up. I'm missing a couple more wires. This is going to plug into, how did I do this before? That's how I had my meter. So we're going to hook this to here. And then I had a cable, another cable, this one. And then this is going to go from here to 5 volts here. ground is connected, and then I need to do from here. Okay, from here to here. This is actually going to go in here. Well, actually it doesn't, yeah. This is going to go in here. I'm missing a connection. Believe it or not, I did this last night, and I just don't remember how I hooked it up now. Okay, so that's connected. That's connected. And this is going to be connected, but that does not feel like what I did before. So the idea is this provides input. Ground is connected, ground is connected, ground is connected. This is the output. Okay, that looks right. Oh, cool, Lance. I didn't realize it's not per button, which actually makes sense because that would be really expensive, and it wasn't all that expensive. Okay, let's get some power. Let this guy in. You know, because I'm distracted, just had a thought. I don't always do this, but I don't entirely trust the load, and I'm a little bit worried about the board, so we're just gonna take one extra step here. Okay, so let's get this, and I'm going to set this to a very minor 500 milliamps. I'm also going to set this supply's limit to 500 milliamps. Now, keep in mind that because this is a boost converter from the input to the output, or a buck converter, sorry. So I'm going from 9 volts down to 5. So if the 5 volt draws 500 milliamps, then the input's probably going to draw on the order of like 300 milliamps. So I set the bench supply to limit at 500 just in case I screw something up. And you got to reduce this voltage down to 4.5 as my warning voltage. And I think we're good to go. Okay, turn that on. No major current draw. Turn this one on. And it immediately, oh, forgot one minor thing. And that is, I don't have the supply enabled. So turn this off. I need to jump from this pin over to the enable pin. All right, let's try that. 24 milliamps. That sounds about right. Turn this on. All right. Since you can't see it, I'll tell you what this says. It says it's drawing 500 milliamps. The output voltage is 4.8 volts. It's supposed to be 5. And so that actually kind of bothers me. The multimeter actually confirms. It says 4.85 as well. Actually says 4.87, but 4.85 is pretty close. Yeah, actually, after I do these measurements, I might, yeah, sorry, Adrian, on the multimeter, I didn't want to spend any more time on that. I actually wanted to use the Mushi meter because then I could have it like right here on the screen. Okay, so this kind of bothers me because this is well below what the output voltage is supposed to be. It's supposed to be 5. I'm only drawing 500 milliamps and it's at 4.8. Okay, so let's, even though that's kind of bad, let's see if we can push it. I'm going to take the current up to 1.5 amps. Let's open this up to 2 amps, or let's go 1.25 amps. And run the test again. Wow. Yeah, so at 1.5 amps, the multimeter is showing that we've dropped down to 4.6 volts, 4.7. The load is saying it's actually about 100 millivolts less than that. And so what's worrying me is this supply, I designed it to handle 3 amps, and I don't see this thing coming even close to that. In fact, let's do this. Let me change which output it's connected to. Yeah, that's okay. Because I want to switch, I want to go to a higher current. Oh, that's not going to work. That's all right. Let's go back to output 1. It's at 8 volts, 5 amps. That's going to be enough. I'm going to take this to 3 amps, and let's just see if the supply even works. No, it's, why did, yeah, it's not even coming close. Okay, so at this point I'm wondering, is it a design problem or is it a problem with this particular board? And so let's back up. I'm going to unconnect this one and grab a second board. Let's see how it responds. So same setup, 12 volts. Connect the enable. Ground and output. No shorts over there. Oh, that's why, because I only had it set to 5. Okay. All right, so 9 volts, 1.25 amps. That's probably going to be fine. Let's drop this back down to 500 milliamps. Turn that on. Drawing 500 milliamps, and now we've got a voltage of about 5.2 volts. And so part of me thinks, uh-oh, this isn't going to work. And so that's, Then I remembered I actually did design it to output 5.2 because I was already thinking about voltage losses and the fact that at 3 amps, I wanted to make sure there was some headroom. So let's kill this guy and go up to 2 amps. Do that again and see what it does then. So at 2 amps, now its output has dropped down to about 4.9. And you know what? I'm okay with that. That's pretty close to what I wanted it to be. And so that's a pretty respectable number. Now, at this point, well, I don't need those. At this point, I really ought to get on an oscilloscope and hook it up to the output and watch what the ripple is doing as we get to these higher loads. But for a quick check that does this load device do what I want it to do, I'm going to say, yeah, sure. It's a constant load, so it's not really going to represent a load device or like a real device, but it does at least give me a good idea on whether or not a supply is working as intended. And so it's at least a good check. I mean, for 30 bucks, I didn't really expect a whole lot more, but you know, that'll work. Now, the one thing you might have noticed throughout all of this is the fan never came on, And that kind of bugs me because I want to see this thing working really hard. So let's think about what could we do. Well, if I come back to my other output, I'm going to configure it for its maximum, which is 8 volts. And it can output up to 5 amps, but I don't need 5 amps. I'm going to go 2.5, I think is about what no, that's not what I wanted. 2.5. So have it limit there. And then on this guy, okay, let me make sure that works before we go to the real test. All right, so that's outputting 4.9 volts, 2 amps, so that's pretty good. Now I'm going to tell this thing to draw 3 amps, which should be the max of this board. It's getting 3 amps. And you probably can't see it on the overhead, but this is saying that the MOSFET is only at 29 degrees. I wonder if you could mod the load to give a load sense to allow for the voltage drop in the leads. Actually, this load does have a, it actually has that ability to compensate already. It's set up for 4-wire measurement. And so you could actually, if I had hooked it up correctly, it would compensate for the loss of the leads. I just don't have enough leads to hook that up the way that is necessary. So you can actually accommodate for it. Hey Pete, good to see you, man. We'll talk about Discord later. Would a large inductor insist on voltage current recovery on the little chip? Yeah, I mean, there's a couple of things that could actually affect the way that this board runs. That was actually one reason why I built built it with 2 different types of inductors. But like I said, I got to get the other ones working. Let's see. Yeah, you know, I wanted to get the fan spinning, but it doesn't really seem to want to do it. Yeah, okay, the supply can't do that much current. All right, there we go. Yeah, the problem is that the power supply keeps dropping. It's not designed for more than 3 amps. So it just turns out that I'm right at the limits of what I can. Try that. Come on, allow. All right. Just for an added bonus. All right. Yeah, actually, what's going on is this regulator, the regulator board is actually going into thermal shutdown. And so let me show you guys this. I know you probably can't read the details, but that's okay. So I just took a thermal image, and so this is the board. So let me hold it this way because that's basically how it is right now. And so right here is where the inductor is, and then right over here is the regulator chip or the switching chip or the switch controller. And so right around here, it's at about 75 degrees C. And so what I'm noticing is when it would hit close to 100, that's when this thing shuts off. So at 3 amps, I'm pushing the limit of what this board can handle, which is okay. I mean, I designed it for 3 amps. It sort of can do 3 amps, but it was never going to actually push out 3. I just wanted that to be its upper limit. Let's see. Heat it up using a matchstick. Yeah, okay. Oh, you know what we could, I know what we can do. I can just hook it up to the load. Okay. Sit tight, man. I'll get the fan to spin now that this experiment's over. But that's pretty cool that these boards actually work as well as they do. If you don't know how switching supplies work, go check out my video on that. It's episode 17 or 18. It was actually one of my more favorite videos to make. It was one of the first ones where I composited in an explosion. Okay, let's move this over here. All right. I'm gonna hook this up to here. So let's just make sure everything is okay now. I don't know what any of this is. Oh, I guess you can't see it anyway. All right, so current, I'm going to drop this down to 2.3, 4 volts. Run that. That's running. Okay. So now this is limited to 5 amps, so let's go up to 4 amps. Okay. Well, it keeps shutting down, which bothers me. I'm not surprised with the little boost converter or buck converter that it was having trouble, but the power supply shouldn't be an issue. Wow. I don't know if you could hear it, but the cooling fan on this guy just kicked in. I don't know that I've ever heard that. So right now I'm at 4 amps, 8 volts. That's about the limit of what I can do. And so even though this is 150 watt, I don't have anything that can push 150 watts. The most I could push is 60. Where's my camera at? Okay, I'm gonna just kind of move this carefully. So I just took a picture from the side, and the hottest spot is the heat sink. This LCD says it's 34 degrees. My thermal camera says 37. It's probably somewhere in between, so I'd say it's actually measuring pretty well. But I mean, it's not even 40 degrees, so that's pretty good. Uh, 3 amps RMS. What's the MOSFET efficiency rating? I have no idea. I don't remember. The LM723 is Pete. Is the LM723? Is that a linear? Is that an op amp? Or is that a regulator? 75 is one. Yeah, so 75C. So regarding the 75C, most I don't need these anymore. Most commercial devices are rated for operation up to either 70 or 85C, and so when I was designing this, that was kind of a conceit, was it's never going to see temperatures above 40C ambient, and so it was supposed to be able to go. It was supposed to get up to 3 amps and be only rise to 85C, but it doesn't look like that's happening. Now, that's probably because I don't have enough heat sinking now that I think about it out loud, but that's okay. Lead acid or lipo can 150 watt. Yeah, huh. I have a spare lead acid battery, so maybe another stream we can do that. Okay. Thermal camera, if you double thing you're measuring, reflective surface. Yeah, actually, good point about the reflectivity about on the thermal camera. I don't entirely believe this particular measurement because it's measuring a hunk of aluminum, and so I'm not getting a proper reading off of it. But in terms of like a ballpark figure, I need to know, is it 30 degrees or 100 degrees? That's what I was looking for in this measurement. But the tape trick actually works well. All right, so I guess let's see, a couple of things from today's stream. Number one, check the show notes or the description for a link to the video that's on element 14, that's on capacitive touch, because I'm going to be covering a project very soon that uses that. If you haven't seen it, on Friday I released the final episode of the Pyramid Arduino design. That's the standalone or DIY Arduino. To me, that one was a lot of fun to make because it was not only, so we got the board back, I soldered parts onto it with my reflow oven, and then I ran into a couple of problems. Now, if you check in the comments, I already admitted this, I actually have two versions of that board. And the first version had an intentional mistake, and it was actually part of the quiz or exercise from the second episode, Designing the PCB. Well, it turns out that when I designed the real board, I had two mistakes on it and totally missed it. And those are actually more interesting than the intentional mistake. So you get to see how I debug through those problems. And then if you've never programmed a bootloader onto an Arduino, that's kind of a fun thing to watch. And I use the logic analyzer built into the scope, so that's kind of cool. Overall, I think it's a cool episode. And then the other thing was to go and check out baldengineer.com because I've been doing some stuff with Arduino in terms of math and using scopes there, which I'd like feedback on this scope article on whether or not I should make that into a video. All that said, I've got some more exciting stuff coming. I've already picked next week's live stream topic, which is unusual. I usually pick it about 10 o'clock on Saturday night. So if you're not subscribed, which according to my stats, 80% of the people watching this video are not subscribed, subscribe now so you know when that comes out. I'm going to wrap up. I'll stop the stream, but I'm going to answer any questions that are left in chat. I want to thank everybody for coming by. In case you missed it at the beginning, my name is James. I'm the Bald Engineer, and thanks for watching an AddOhms live stream. If you find these videos helpful, please consider supporting AddOhms and the Bald Engineer on Patreon.